Hello student and welcome to my channel, that is Easy Chemistry by SBG. Today we will solve some spectroscopic problem based on the IR and H1 NMR spectroscopy. The question is like the proposed structure for the compounds with the following spectroscopic data. Data is given here. Such a problem may ask for the 3 marks. Now see the first problem. Molecular formula is given. C3H6O, IR value is 1710 and 2720 per centimeter. Proton magnetic resonance spectroscopic data is given. First is 9.77 delta for the one hydrogen, and this hydrogen gives the singlet. Second is 2.5 delta 2 hydrogen quartet. Third is 1.2 delta 3 hydrogen triplet. The first step while solving spectroscopic problem is the site of unsaturation. Site of unsaturation is calculated by the formula, that is 2 into the number of carbon plus 2 plus nitrogen minus hydrogen and halogen divided by 2. So there are 3 carbon, so 2 into 3 plus 2, there is no any nitrogen, so minus 6 number of hydrogen and no any halogen, so this will become 3 into 2 6 plus 2 8 minus 6 divided by 2 is equals to 2 by 2 is equal to 1. So the site of unsaturation is equals to 1. Now the IR value at the 1710 and the 2720 per centimeter indicates presence of the carbonyl group. Presence of carbonyl group. So this is a 2720 per centimeter IR value indicate the presence of aldehyde group. Presence of aldehyde group because the 2720 per centimeter value is the stretching frequency of CH bond in the aldehyde. Now see the next PMR data. 9.77 delta for one hydrogen indicates the aldehydic hydrogen. Then the quartet for the 2 hydrogen, CH2, it shows the quartet. Quartet means this CH2 must be attached to the neighboring 3 hydrogen, this one, and this hydrogen shows, this 3 hydrogen shows the triplet because it is attached to the carbon or attached to the CH2 group, and these are the 2 fragments. If we connect this fragment like this, CH, C double bond O, CH, then CH2, CH3. Now match the data given. Now molecular formula is matched here. Site of unsaturation is 1, that is the C double bond O, site of unsaturation. Then these 2 hydrogen shows the quartet because its neighboring carbon bears the 3 hydrogen. Now this 2 hydrogen shows the quartet at 2.5 delta value. Then this 3 hydrogen shows the triplet at 1.2 delta value, and this 1 hydrogen shows the singlet at 9.77 delta value. And the stretching frequency for this carbon hydrogen aldehydic bond is 2720 per centimeter, and the stretching frequency for the aldehydic carbonyl group is 1710 per centimeter. So the data is matched to the reduced structure. See the next next problem. The data is given here. Molecular formula is C5H10O. Site of unsaturation calculated here. site of unsaturation, 2 into carbon plus 2 plus nitrogen minus hydrogen minus halogen upon 2. So the site of unsaturation is equals to the 1 site of unsaturation. Now the 1710 per centimeter value indicates the carbonyl stretching frequency. The IR value at 1710 gives the presence of carbonyl group, and the 1 site of unsaturation is also masked. Then see the PMR data. The 6 hydrogen shows the doublet. 6 hydrogen shows the doublet, means CH3 and second CH3. This total are the 6 hydrogen, and this shows the doublet, means this CH3 attached to the carbon containing 1 hydrogen. Now this 6 hydrogen shows doublet, and quite shielded value, that is 0.95 value. Now the 1 hydrogen, that is this hydrogen, shows the multiplet, because this hydrogen attached to the carbon and this carbon is attached to the 2 CH3 group. That's why this hydrogen coupled with this hydrogen and showing the multiplet at 2.43 delta value. 2.43 delta value. So this fragment is fixed. The next PMR data is for the 3 hydrogen, and which shows the singlet CH3, and it shows the singlet at 2.1 delta value, and it is quite de-shielded one. Now if we join this fragment, the fragment A, fragment B and fragment C, when we join this fragment in such a way, this data must be masked. So we get ketone C double bond O CH3 CH CH3 CH3. Now the data is also masked. This CH3 shows singlet at 2.1 delta value. This 6 hydrogen shows doublet at 0.95 delta value, and this 1 hydrogen shows multiplet at 2.43 delta value, and this carbonyl stretching frequency is 1710 per centimeter. It is low because this inductive effect of the alkyl group. Now see the next problem. Molecular formula is C3H8O. C3H8O. IR is 1715. Site of unsaturation. Site of unsaturation. Don't consider the oxygen while calculating the site of unsaturation. Now site of unsaturation, same formula, 2 into carbon plus 2 plus nitrogen minus hydrogen minus halogen upon 2. So the site of unsaturation for this molecular formula is 0, means no site of unsaturation. No site of unsaturation. Now see the IR data. IR data shows the 1715 per centimeter, and oxygen is also given, but there is a no site of unsaturation, means no site of unsaturation. So see the IR value. IR value shows the range in 1100 to 1300. Then there is a presence of the ether. That means the O linkage. So see the PMR data. In PMR, triplet at 1.03 for the 3 hydrogen. So this 3 hydrogen shows triplet. When this 3 hydrogen is attached to the 2 hydrogen bearing carbon, then this 3 hydrogen shows a triplet at 1.07 delta value, and this 2 hydrogen must show the quartet, and see this showing the quartet at 2.48 delta value. This is a one fragment. Then half PMR data shows the 3 hydrogen singlet for the 3 hydrogen. Now this 3 hydrogen shows the singlet, and at 2.12 delta value. This CH3 shows absorption at 1.07 delta value, while this CH3 shows the absorption in PMR at the 2.12 delta value, because this CH3 must be attached to the oxygen. So if we attach the fragment by matching the spectroscopic data, so we get the O, CH2, CH3 and CH3 here. Now see, this CH2 shows the quartet as 2.48 delta value, quite deshielded because it is near to the oxygen. This CH3 shows the triplet at 1.07 delta value, and this CH3 shows the same singlet at 2.12 delta value. So this structure is matched to the given spectroscopic data. Now see the next problem. Molecular formula is C3H5ON. Molecular formula is C3H5ON. So the site of unsaturation, first step is site of unsaturation, 2 into number of carbon plus 2 plus number of nitrogen minus number of hydrogen and minus number of halogen divided by 2. So 2 into 3 6 plus 2 8 plus 1 9 minus 5 hydrogen, there is no halogen, divided by 2. So 4 by 2 is equal to 2 sides of unsaturation, 2 sides of unsaturation. See the IR value. IR at 2250 per centimeter indicates the presence of triple bond. IR at 2250 per centimeter indicates presence of triple bond. The triple bond may be in between the carbon triple bond or the carbon triple bond, or maybe the carbon nitrogen triple bond. There may be the presence of this fragment or this one. Now see the PMR data. PMR data at the 3.49 delta 3 hydrogen shows the singlet, that is the CH3 must be present, and it shows singlet means no any hydrogen near to the carbon at which this CH3 is attached. So it shows singlet at 3.49 delta value. Second PMR data suggests that the singlet at 4.22 delta for the 2 hydrogen CH2. These 2 hydrogen also shows the singlet. These 2 hydrogen also shows singlet at 4.22 delta value. It is quite deshielded one. It must be attached to the triple bond. Now see the carbon are already 3, first, second, and these 3, and 1 is the nitrogen, and there is a no any stretching frequency for the NH and no any hydrogen showing the broad band at the IR spectra. So there is a absence of NH. So the fragment must be the C triple bond N, then CH2 and CH3. So attach the fragment with matching the spectroscopic data, we get the CH3, then one oxygen is there. Now this CH2 shows quite high value, that is 4.22 delta, it is de-shielded one, and this CH3 is also de-shielded, that is 3.49 delta value. Means the oxygen must be present in between these two groups. So oxygen is in between the CH3 and CH2, then the next fragment is C triple bond N. Now see, this spectroscopic data is matched to the structure. The carbon-carbon triple bond, this stretching frequency is 2250 per centimeter. Then this is the value for this CH2, and this is the value for this, and these are the de-shielded because this CH2 is more de-shielded due to the presence of this cyanide and oxygen. The CH3 also de-shielded due to the presence of oxygen or attached directly to the oxygen, and they both, in CH3 and CH2, shows the singlet. See the next problem. The data is given here, the spectroscopic data. Molecular formula is a C8H9Br. C8H9Br. Site of unsaturation, again same formula, 2 into number of carbon plus 2 plus nitrogen minus hydrogen minus halogen upon 2. So 2 into 8, 16. 16 plus 2, 18 minus 10. 10 means 9 hydrogen and 1 halogen, 10 divided by 2. So 8 by 2, it shows 4 site of unsaturation. 4 site of unsaturation indicates the presence of benzene ring because it is matched to the PMR data also. So the 4 site of unsaturation shows the presence of benzene ring here. Okay. And this 5 hydrogen shows the singlet. This 5 hydrogen shows the singlet at 7.3 delta value. The 6 to 8 delta value indicates the presence of benzoic hydrogen. Now this is a substituted benzene ring must be. See the another spectroscopic data, PMR, doublet at 3 hydrogen, CH3. This CH3 shows doublet. This CH3 shows doublet at 2 delta value. It shows doublet, mean it must be attached to the carbon having the 1 hydrogen, and this 1 hydrogen shows the quartet. This hydrogen shows the quartet at 5.15. This hydrogen must be attached to the CH3, but this value is quite de-shielded, means it is attached to the electronegative element and which is already present, that is the bromine, and this the valency. Now attach this fragment in such a way all spectroscopic data must be matched, so we get the proper structure. So see, this is our benzene, substituted benzene. Now this CH attached to the bromine and benzene ring 2, because the value of this hydrogen is quite de-shielded, that is 5.15 delta value it is. And next one is the CH3. This will be the structure for this data. Now see the singlet. These 5 hydrogen benzoic hydrogen this hydrogen shows the singlet, this hydrogen shows the quartet, because this hydrogen is attached to the this hydrogen having the nearby 4 hydrogen. This hydrogen must shows the doublet, and it shows doublet at the 2 delta value, and this hydrogen is de-shielded and it shows the 5.15 delta because it is attached to the benzene ring as well as bromide. Now last numerical of this session is molecular formula is given. The molecular formula is C4H5O2N, C4H5O2N. The site of unsaturation, 2 into 4 plus 2 plus 1 minus 5 divided by 2. This 2 into number of carbon 4 plus 2 plus 1 nitrogen minus 5. So it shows 3 site of unsaturation. 4 into 2 8 plus 2 10 plus 1 11 minus 5 6 by 2. It is a 3 site of unsaturation. Site of unsaturation. Again there is a presence of nitrogen and IR value is 2250, means it indicates the presence of carbon nitrogen triple bond. So IR at 2250 per centimeter and presence of nitrogen indicates the presence of cyanide fragment. So next is the IR stretching frequency at 1715 per centimeter indicates presence of ester, group. So there is a presence of 2 oxygen and the site of unsaturation is also 3. So the ester is there. So O, this fragment must be there. Now see the PMR data. PMR data for 2 hydrogen shows the singlet. PMR data. 2 hydrogen shows singlet, means CH2. 2 hydrogen shows singlet, means this 2 hydrogen or this CH2 is present in such a way that there is no any hydrogen next to this CH2. Then second PMR shows the singlet for 3 hydrogen. This 3 hydrogen shows singlet. Now this 3 hydrogen is quite de-shielded, means this 3 hydrogen must be present in the ester group. Now if we join this fragment, that is C triple bond nitrogen, then carbonyl, then we get the structure like the N triple bond C, then CH2, C triple bond, sorry, C double bond O and OCH3. This CH3 shows the 3.8 delta value singlet. Now this CH2 also shows the singlet at 3.5 delta value. It is also singlet. Now this is the proper structure with matching the spectroscopic data given here, and this carbonyl stretching frequency is given as 1715 per centimeter because it is ester stretching frequency, and this stretching frequency for the carbon nitrogen triple bond is 2050 per centimeter. This is an correct structure. If you like my video, please share, subscribe and like, plus press the bell icon so whenever I add the new video you will get the notification. Thank you.